Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have this function. It is 2e to the power 3x plus 3e to the power negative 2x. And we have to find the second derivative of this function. So, in order to compute second derivative, we first have to compute first derivative and then take the derivative of the first derivative. That's how we will get our second derivative. So, let me quickly remind you that when you have an exponential function and you are taking the derivative with respect to x and say the function is of the form e to the power u. So, this u is a different function and it is a function of x. Then the derivative is computed this way. It is e to the u times du dx. So, we will be using this formula for derivative for all the different exponential functions. Okay. So, let us start with computing the first derivative. So, what is f prime of x? Well, that is the derivative d dx of this entire expression, 2e to the 3x plus 3e to the negative 2x. Now, let us split this entire derivative into two separate derivatives. First, so this is equal to d dx of 2e to the 3x plus d dx of 3e to the negative 2x. Now, notice this 2 is just a constant, so we know that when we will take the derivative, we will write down this 2 and then we have to take the derivative of this exponential function. So, whatever is in the exponent, this 3x is like the u here. So, let us apply this rule. So, the derivative of e to the 3x or e to the u is, you write down e to the u and then you have to multiply with the derivative of that u as well. So, that is the formula. Let us do it again for the second term. Notice this 3 will just be 3 because it will be multiplied, and then in the function this negative 2x, this entire thing is your u. So, when you apply this rule, we will have e to the negative 2x. So, write down the function as it is and then multiply with the derivative of negative 2x. Okay. Now, let us simplify. This is 2e to the 3x and then d dx of 3x is just 3 times 1 plus 3 times e to the negative 2x, that whole thing remains as it is, and the derivative of negative 2x is just negative 2. Let us multiply these constants together. This is 3 times 2, 6e to the 3x, and this is negative 2 times 3, so negative 6e to the negative 2x. So, this expression is the derivative, the first derivative of the given function. All right. Now, let us move on and figure out the second derivative. And the second derivative is represented as f double prime x. And the definition is, this is the derivative or d dx of the first derivative. So, d dx of this last expression that we have. So, 6e to the 3x minus 6e to the negative 2x. All right. And we follow the same way. We first split it into two separate derivatives. So, we have d dx of 6e to the 3x minus d dx of 6e to the negative 2x. Okay. Now, notice again this 3x in the exponent is like the u. and we will be applying this rule one more time. So what is the derivative? The 6 comes down, and this is d dx of e to the u. So you write down the exponential function as it is, so e to the 3x, and then multiply with the derivative of the u, whatever is in the exponent, and that is 3x. Okay, let's do the same thing for the second expression. 6 just comes down, and e to the negative 2x, this negative 2x is now the u. So the derivative is write down the function e to the negative 2x as it is and multiply with the derivative of the exponent, which is negative 2x. Okay, let's simplify. So 6 e to the 3x. Now derivative of 3x is just 3. Minus 6 e to the negative 2x, keep that portion as it is. And d dx of negative 2x is just negative 2. Then combine all the constants together. So 6 times 3 is 18. So this is 18 e to the 3x. And there we have negative 2 and negative 6. So you get positive, and 6 times 2 is 12 e to the negative 2x. This expression, this final expression, gives us the second derivative of this function f. Thank you.